So first part of today's lesson, we're going to talk about finding equations or finding slopes of lines to determine if two lines are indeed perpendicular, parallel, or neither to each other. So the first part of this example, part one of this example is we're given 4 points. 2 points connect to each other, the other two goes to each other, and we're going to determine if these lines will intersect or they're going to be parallel or they're going to be neither. Okay, so the first part here is we're going to find with the 2 points that is given to us to signify AB. AB here refers to a line AB. So find the slope of line AB, find the slope of line CD, and if the slope comes out to be the same, both at the same line, same slope, we call that parallel. Okay? If the slope of those two things are the negative reciprocal of each other, then it's perpendicular. And the last one is if the slope is neither reciprocal, it's neither parallel nor perpendicular, then it's going to be neither. Okay? So the equation that you need to remember from here is determine what is the slope. The slope is given by 0.2 y value minus 0.1's y value divided by 0.2's x value minus 0.1's x value. And then do the subtraction and make sure consistent. y2 minus y1, x2 minus x1, or you can do y1 minus y2, or divided by x1 minus x2, but make sure you're consistent. Always the second number is always first. So just be consistent here. So the first example from this handout that Mr. What's his name? Mr. Pittman's going to give you. So for this example, AB formed by points negative 2, 3, and 2, 6. So those are the 2 points that form line AB. And then CD is formed by negative 1 and 0 and 3, 0. 3, 3, so this is point C, point D, point C, point B, and point A. So in that case, we're going to determine what is my slope for line AB. So line AB, this is my second point, this is my first point, so I did 2, 6 minus 3, which is 3, and then 2 minus 2, which is 2 plus 2, which is 4. So that's the slope for AB. Now, for the second part of CD, the slope of CD is given by 3 minus 0 divided by 3 minus 1, which is 4. So since these two numbers are the same, it's going to be parallel to each other. So these two lines are parallel. Now, example number 2, we're given again 4 points. AB is formed by 0, 2 and 5, 4, and CD is formed by 1, 8 and 3, 3. So the slope here is going to be determined by, in this case, AB, the slope of that would be 4 minus 2, which is 2, 5 minus 0, which is 5. CD, the slope is going to be 3 minus 8, which is equal to negative 5, and 3 minus 1, which is equal to 2. So in this case, if you look at this, it's the reciprocal, negative reciprocal makes that perpendicular. So these two lines are perpendicular to each other. So remember, when you multiply the two slopes, if they're perpendicular, if you multiply this by this, you get a final answer of 2 times negative 5 divided by 5 times 2, which is negative 1. Okay? Now, so here are the two examples. So the next example I'm going to give you here is going to be talking about given two line equations. And you're going to have to determine if the lines are parallel, perpendicular, or neither. So the steps here is number one, always convert to slope-intercept first. So in that case, if it's given a slope-intercept, then just use that and determine what my slope is. Or if you're given a standard form, then just rearrange equations so you get y is equal to mx plus b form. So step 1 and step 2, convert these two equations if they are not in slope-intercept form. If they are, then just continue to step number 3. You compare slopes. If the slopes are the same, it's parallel. If the slopes are the negative reciprocal of one another, then it's perpendicular. If it's neither parallel nor perpendicular, then it's going to be neither. So you're going to do example 9 from that handout. So equation number 1, we're given that y is equal to 7x plus 2, and the second equation is 7x minus 1 equals 1. So this is already in slope-intercept form, so you're going to look at this. Slope is 7, slope is 7. Then that means we can conclude that these two lines are parallel. Example number 12, we're given this equation 1 is given in standard form. The second one is given in, unsimplified slope-intercept form. So in that case, you can't just go look at that and say my slope is 18. Okay, you got to make sure it's y is equal to something by itself. So by this first equation, I rearranged it to get 6y is equal to 3x minus x, and divide everything by 6. I end up with y is equal to 5 minus x over 6. That means my slope here is equal to negative 1, 6. Now, the second equation here, I need to divide everything by 3 to get y is equal to mx plus b form. So in that case, divide by 3. So 18 divided by 3 is 6. 6 divided by 3 is 2. So that means my slope of my equation is y is equal to 6x minus 2. So the slope of equation 1 is negative 1, 6. The slope of equation number 2 is 6. So they're negative reciprocals of one another. That means my line here, these two lines here are perpendicular. Okay. Last but not least, example number 16, y is equal to 6, x equals to negative 1. Okay, y is equal to 6 is a horizontal line, x equals negative 1 is not a function, but it's a line, vertical line. So that means my slope here, I don't have a slope. My slope is equal to 0. Whereas for this one, x equals negative 1, you cannot ever write this in terms of y, so that just means my slope is undefined. Okay, so you have one looks like this, one looks like this. In that case, my conclusion is that these two lines are perpendicular. Okay, so now Mr. Pittman will assign you a couple questions to practice with, and then we'll move on to the next video. See you in the next one.